In this project, we work on an application that uses machine learning to understand Amazon product reviews. So every day, people now leave a lot of reviews online, but reading all of them is time consuming. Also, star ratings alone don't always tell the full story, so our goal is to predict star ratings and overall sentiment directly from the review text. This kind of application can help customers quickly understand product quality, help sellers summarize the feedback, or may help platforms analyze reviews at scale. So to do this, we treat the problem as a supervised text classification task, and we compare several different machine learning models from simple baselines to more advanced models like transformers. So first, we load the dataset from a CSV file. We manually collected it from Amazon, and each data point contains the review text and the star rating from 1 to 5. And after cleaning the data and removing the missing values, we end up with about 500 reviews. And we then split the data into training, validation, and test set in this part. And before training a model, we create a baseline. This baseline always predicts the most common star rating in the training data. It gets about 20% accuracy, which gives us a lower bound for the comparison. And after that, we train our first real model, TF-IDF plus logistic regression. TF-IDF turns the review text into numerical features, and logistic regression predicts one of the 5-star ratings. The model reaches about 48% accuracy on the test set, which is a big improvement over the baseline. We also show a confusion matrix and look at a few wrong predictions to understand the errors. You can see from this part, see all the error analysis examples. And in the next part, we try another traditional model, TF-IDF with a linear SVM. The tasks stays the same, predicting 1 to 5 stars, but we replace the logistic regression with an SVM, which often works well for the text data. We also do the same things, you can see, and we train the model, evaluate on the test set, and visualize the result using the confusion matrix. And this accuracy is slightly lower than the logistic regression, but still competitive. Next, we improve the SVM model by adding the truncate SVD, which is similar to PCA. Here, we reduce the TF-IDF feature size from 5,000 dimensions down to 100 dimensions before training the SVM. This helps reduce the noise and improves the efficiency. And this optimized model achieves similar accuracy around 47%. And we also inspect the model's weights to find keywords strongly associated with 1-star and 5-star reviews, which helps with the interpretability. And you can see this shows the result. And predicting exact star rating is hard, even for humans. So in the fourth block, we simplify the task. We map 1 to 2 stars to negative, 3 stars to neutral, and 4 to 5 stars to positives. And we train the same TF-IDF model plus SVM. With this reformulated task, the accuracy improves to about 63%, showing the predicting overall sentiment is easier than predicting the exact number of stars. And in the fifth block, we move to a deep learning approach using a distilled BERT, a pre-trained transformer model. Instead of TF-IDF, we used a tokenzer to convert the text into tokens and fine-tune the model on our data set. So we evaluate the model using accuracy and macro F1. We also analyze the most confident mistakes to see where the model still struggles. As you can see from these results, the classification report, and also it will show the top confusion pairs and the review. This is the result example. As you input, this product is terrible and broken up in 1 day, the prediction result will be 2 stars. And finally, we train a multinomial naive Bayes model. Bayes model using a count vectorism. This is a classic text classification baseline. It's simple, fast, and interpretable. We evaluate it using accuracy, precision, recall, and F1 score, and we also show example prediction with probability distribution over star ratings. As you can see from this part, the result will show in this part, the confusion matrix. We also enter some examples review. If you enter this product absolutely terrible, waste of money, it will give you the result prediction 1 stars. So to summarize, we experiment with several different machine learning models for review classification, and the baseline performance poorly with about like 20% accuracy, showing the problem is non-trivial. So the traditional model like TF-IDF with logistic regression or SVM perform much better, but using dimensionally reduction helps more with the efficiency. And when we use the bird it shows the potential of deep learning for capturing the sentiment meaning, although its performance is limited by the small data size. So overall, this project shows how different machine learning approaches trade off simplicity, interpretability, and performance with solving real-world text classification problems. Thanks for listening.